Hello, my name is Katie Nichols, and I'm the Marine Restoration Director with Orange County Coastkeeper. And today I'm going to talk about native oyster restoration using novel materials. I first want to thank my co-authors, Dr. Christine Whitcraft from Cal State University Long Beach and Dr. Danielle Zackrell from Cal State University Fullerton. A brief outline of my talk: I'm going to introduce you to our native Olympia oyster, talk about oyster restoration using coconut coir, the successes and challenges with small-scale oyster shell recycling, and further research. The Olympia oyster, Ostrea lurida, is the only native oyster to the U.S. West Coast. It's found in bays and estuaries, and it cements one shell to hard surfaces and forms complex structured habitat. It was once prominent, but is now almost functionally extinct in Southern California, with over 90% loss. And it's depleted due to a variety of human factors, including overharvesting, dredging, and pollution. But restoration efforts are underway along the coast. And fortunately, in Southern California, we have enough remnant populations that we're not limited by the amount of larvae in the water column. If we build the right habitat, we think the Olympia oysters will come back. My colleagues and I have been restoring the Olympia oyster for several years now. And my colleague is an expert in Olympia oyster biology, Dr. Zackrell from Cal State Fullerton. And we've looked at using different configurations of shell, whether loose or bagged, and what tidal height and what thickness to optimize the settlement of the Olympia oyster. And we've worked at two main sites in Southern California: Newport Beach at the south end of Orange County, and Long Beach a little bit further north, and specifically in Alamitos Bay. And today I'm going to talk about the methods for oyster restoration. So in Upper Newport Bay, we are restoring the native oyster with and without native eelgrass in a living shorelines configuration to look at how these species interact and may provide co-benefits. But today I'm going to focus on the oyster shell, but I do want to give a shout out to that species eelgrass that we love as well. So for this, we used clean Pacific oyster shell, about 40,000 pounds, that we initially purchased from an aqua farm in Carlsbad. And we put this shell out in hand-sewn coconut coir bags. You can see a picture of that coir in the right-hand side photo towards the bottom. I'm going to go into depth a little bit about that material. This project involved a ton of volunteers and was about 200 square meters. And then at the end, I'll talk a little bit about Alamitos Bay and our efforts there, a little bit smaller with about 3,000 pounds of shell and about 80 volunteers. So the coconut coir, so you get a sense of what it looks like. It's used a lot in erosion control and not so much in oyster restoration. It's sort of a new material for this use. That person on the left side is actually quite tall. It comes in rolls about 6 feet. And we cut it using hedge trimmers and then hand sewed it using volunteers. Our initial goal was about 1,000 bags, and we made it to about 500 because this was a very time and labor intensive effort. I highly recommend providing incentives to your interns and volunteers. So that side right photo is a photo of our sip and sew that we held at a brewery. So maybe quality of the sewing went down a little bit, but our volunteers were a little bit happier. This is a picture of the coir up close and what a finished bag looks like. So they were about 1/2 meter by 1 meter long, and they weighed about 20 to 30 pounds. For transport, we didn't really use any large structures or equipment. Most of this was transported via volunteers, personal vehicles, boats, and by hand out onto the mudflat. So this is what the restoration looked like in action. We had some mussel shell from the aqua farm that we put down as a first layer with just 1 layer of coir because we expected some subsidence initially, and then placed those hand-sewn bags on top. On the right-hand side is what a finished product looked like at one site, so about a 20-meter long bed with drainage channels built into it. Very important lesson we learned early on. And a shout out to over 250 volunteers that helped us out at 3 and 4 in the morning placing this shell on the mudflat. After about a year, we had native oyster densities that were over 14 times higher on our restored site than initial densities, and over 6 times higher than nearby reference sites. After 2 years, we have consolidated native oyster beds living at 2 of our sites, and we just finished our 3-year sampling effort, so we'll be able to see how these beds have changed over time. This is a graphic of the 2-year post-restoration data compiled by my colleague, Dr. Zackrell, who's leading up some of the quantitative sampling efforts. And on the x-axis, we have site, and then on the y-axis, we have oyster density. And you can see that regardless of whether or not eelgrass beds were present, native oyster densities went way up when we had a restoration at the treatment site versus a control. One of the challenges of our project is that we're in a highly utilized recreational bay. It's used by paddleboarders and kayakers, as well as recreational fishermen. We are in an estate marine conservation area where collecting from shore is not allowed, but fishing with hook and line from shore is allowed. So what ended up happening is fishermen were inadvertently hooking some of the shell bags with their hooks and bringing those up onto the beach. So in this photo on the left, you can see that happening, one of the bags pulled up on the beach and ripped open, unfortunately. So a strategy to kind of prevent this, what we did was provide outreach to people at the beach, educate them about the different habitats and how we were restoring them, provide flyers in a variety of languages. And we also worked with the city to install additional MPA signage to let people know that they were in a marine protected area. So although we had some disturbance, we wanted to maintain our restoration footprint. And so instead of adding more shell to the damaged beds, we decided to add on new beds adjacent to them because we didn't want to add shell onto those existing beds because we still had high oyster densities there, even where we had some disturbance. So this is a photo of how we did those new beds last year. And we used the coconut coir in a slightly different way. I did not want to sew bags by hand again, although it's a great effort and people did somewhat enjoy it, a lot of work. So we ended up using a different method and sort of wrapping them like a burrito and hand tying them in the field. And this allowed for more continuous pieces that would be less likely to be pulled up by fishermen. We also built these at 2 different tidal heights so that we could see whether or not tidal height would influence oyster dynamics. This is a picture of that coconut coir of those newer beds 6 months later. We've been really interested in how that coir breaks down over time. And anecdotally, it's lasted quite a bit longer than I initially thought it would. We do have fairly low wave energy sites, but they do get boat wakes. And so we've been documenting the coir breakdown via photo plots, as well as annually monitoring for percent shell cover, bed height, rugosity, and the dimensions. So see how these beds are changing in configuration over time. Bed integrity and quantifying it and how to maintain these over time has been another challenge of ours. So the picture on the left is a bed once it was initially built, and the picture on the right is a couple of years later showing how it's spread and the coir has broken down. Now, bed integrity and shell cover have varied across the sites, but we haven't seen a relationship between bed integrity and proximity of eelgrass. So again, the photo on the left is a bed once it was initially built. In the middle, you can see one of the sites, the shell has remained pretty consolidated and kept some of its integrity, versus at other sites where it's more spread out. And beds at all of the sites except one have migrated upshore as well. So we've been looking to tease out what factors are causing differences in bed integrity among the different sites, whether that's maybe some human activity. So as I mentioned, all of our sites are in a state marine conservation area, but one of our sites is also in an ecological reserve that does not have any public access. So that could potentially be a factor. There may be some differences in wave energy or boat wakes among the sites. And then sediment and upshore marsh connectivity also might be playing into these effects that we're seeing. Lastly, I wanted to mention our Alamitos-based site. Fortunately, we were able to get a bunch of volunteers out in March of this year, right before kind of COVID hit, and we built a 30 square meter bed, similar to those mini beds in Newport. We used longer pieces of coir and a contiguous bed. So we're hoping to get out this spring and see how those have held up over time. The challenges that we've had in shell recycling, particularly for Southern California, the big one is space. So finding storage space has been a real challenge. So our first shell was stored at a boat yard, and we had to use some creative methods to containerize it and transport it using trash cans and a variety of containers to sort of move it around. And then funding for that is also a challenge as a small nonprofit. So we have done some shell recycling efforts with restaurants as well on a pretty smaller scale. And fortunately, we recently developed a partnership with Irvine Ranch Water District, who is donating space for free to us in their corporate yard, which removes some of the issues that we'd have with pests and smell if you're curing shell outside in sun, which is the ideal way to do it. And so you're not having an area that has public access where you might have, you know, problems with having pests or smell issues there. So further research, there's a ton of things we still want to look at, including expanding and extending our biological monitoring, figuring out the best ways to adaptively maintain the restoration sites, expanding our work on sedimentation and shoreline erosion, utilizing LIDAR and GIS. We're also currently looking at how human use of the restoration sites might affect bed integrity. Lastly, I want to thank my collaborators and funding sources. I particularly want to acknowledge the Pacific Marine and Estuarine Partnership, or PMET. Definitely check them out. They're a pretty cool fish habitat partnership here on the West Coast. If you have any questions, feel free to check out our website at coastkeeper.org or shoot me an email. My email is katie@coastkeeper.org. Thank you so much for joining me today and listening to the presentation. See you later.